So far to this point, most of the solving equations that you guys have been doing has been using algebra tiles and doing it on an equation mat and then recording your work in a table so other people can see how you solved it. Sometimes though, we work with equations that either have numbers that are too large to build with tiles, or maybe we have decimals or fractions, or maybe you just find the tiles are starting to get cumbersome and you want another method. So today we're going to look at how you can solve and check equations algebraically. And I'd like you to copy these examples down as we go. Alright, example number 1. We have 3x plus 3x minus 1 is equal to 4x plus 9. Alright, what I'm going to be doing from this point on is drawing a line through our equal sign to remind myself that I've got a left side of the equation and a right side of the equation, and I need to keep those two separate. It kind of is a visual, just like on your maths. Alright, and now I look and I see, what can I do on the left to simplify? Well, if I was building this with tiles, I would have 3x tiles and 3x tiles. Well, I can just combine those right away to get 6x, alright, and then I'm just going to bring down this negative 1 or minus 1 and say that's equal to 4x plus 9. We didn't do anything different on that other side, we just kind of brought everything down. But we did this here, we combined our like terms. Alright, now I'm looking, and again, I'm kind of just starting here by picturing an equation mat, and I would see that I would have 6x tiles on the left and a red unit tile, and I would have 4x tiles on the right and 9 unit tiles. Well, I've got to get my x's positive and all on one side in order to solve my equation. And to do that at this point, I see I've got 6x over here and 4x over here. What would make the most sense to me is to get rid of this 4x by adding, negative 4x. But if I do it to the right, I have to also do it to the left, right? It's like adding 4 red x's to your mat. Alright, and now I see, what do I have left after I do that? Well, I had 4x and I added negative 4x's, so that cancels out or makes a 0 pair. So on the right, I just have 9. Okay, but now over on the left side, on mat A, I would have 6x plus negative 4x. And I see that would be 2x that's left. And I still have this minus 1 I'm just going to bring down. Okay, we still don't have our x's alone though, but we do have them all positive. So that's a step in the right direction. Now we need to get rid of this minus 1 that's on the same side of the mat as the x's. So I'm going to get rid of that by adding 1. But remember, if you do it to one side, you have to do it to the other. And now what I have left on the first side, this cancels out. I have 2x equals 10. But again, I don't want to know what 2x's are, I want to know what x is. So I think, how can I figure out just 1x if I have what 2x's is? Well, I divide both sides by 2. Okay, and 2x divided by 2, well, there's a giant 1 in there, so 2 divided by 2 is 1, and 1x is just the same thing as x, and then 10 divided by 2 is 5. So I found my answer to be x equals 5. Now we need to check it to see, let me see if I can slide this up here, sorry, bear with me. Here, we'll shrink that down. I need to check it and see if my answer works. So to do that, I'm just going to take this answer of x equals 5, and I'm going to put 5 in to my original equation everywhere I see x, and then simplify and see if the left side of the mat equals the right side of the mat. So I'm going to do 3 times 5 plus 3 times 5 minus 1 equals 4 times 5 plus 9. And I see that 15 plus 15 minus 1 equals 20 plus 9. I'm just simplifying down my page here using the order of operations. And then 15 plus 15 is 30, and 30 minus 1 is 29. So I'm hoping that the right side also equals 29. And if I have 20 plus 9, I see that it does. My answer checks. I checked my answer of x equals 5, so I know that it's correct. Example number 2 says negative 3x plus 7 equals x minus 1. Again, I like to start by drawing in my center line here just to remind myself that I'm splitting the left side from the right side. Alright, and my goal here again, always get my x's on one side of the mat and positive, and everything else on the other side of the mat. So I've got negative 3x on the left and x on the right. Well, I want to get rid of this negative 3x because I want everything to be positive. So I'm thinking, what can I do here? What can I add to it that will cancel that out? And I know that if I add the opposite, that is going to make a 0 pair. But if you do it to the left, make sure you do it to the right also. And I see that negative 3x plus 3x, well, that cancels out. And so I'm just left with 7. And on the right side, I have x plus 3x, and that's 4x. And then I just bring down my minus 1. I didn't do anything different over there. Alright, next step. Now I've got my x's positive on one side of the mat, so now we need to get rid of anything else that's over there. And I see I've got this minus 1, or picture again a red unit tile over there. So what can I add to it to get rid of it? Well, I know if I add 1, that's going to make a 0 pair over there, and I'll be able to get rid of it. But if you do it to the right, you've got to do it to the left. Alright, so let's see what we have on each side of our equation now. We've got negative 1 plus 1 cancels out. And so on the right I just have 4x, and on the left I have 7 plus 1, which is 8. And now I've got 8 is equal to 4x. Well, my last step will be to divide by however many x's I had. So I had 4 of them, so I'm going to divide both sides of my equation by 4. And 4x divided by 4 is just x. And then 8 divided by 4 is 2. So what I found here is that my answer is x equals 2. I'm going to check it by putting it back into my original equation. See, I've got negative 3. Instead of x, I'm going to put 2. So times 2 plus 7 equals, again, instead of x, I'm going to put 2. Oops, I didn't really need parentheses there. Minus 1. And then I simplify this. Negative 3 times 2 is negative 6 plus 7. And then 2 minus 1 is just 1. And negative 6 plus 7 is 1. And I see that my left side equals my right side, so my solution here works. This checks out. Alright. Alright, our third example includes needing to use the distributive property to solve it. So let's take a look at this one. On the left I have 3 times x minus 1 plus 1 minus 2x equals negative 4 plus negative x minus 2. And I'm going to split that so I keep my left and my right separate. Alright, and now I'm going to look at the left hand side, and I see right away I need to distribute where I've got this 3 times x minus 1. I need to get rid of those parentheses. So I'm going to do 3 times x, which is 3x, minus, because I was subtracting up there, 3 times 1, which is 3. I'm just going to bring down the rest of my equation. So I'm not really doing anything different over there. Oops, minus 2. Okay, so now that I have the distributive property done, I can start combining like terms. And I see on the left I've got 3x and negative 2x, or I could read this as 3x minus 2x. And I know that just leaves me with x. It's 1x, or just x. And then I see I have negative 3 plus 1. Well, I know that's negative 2. So I'm going to bring that down. And I also need to simplify the right side, and I see that I've got negative 4 minus 2, which is negative 6. And then I've just got plus negative x. Alright, at this point now, I've combined all my like terms, and now I'm trying to get my x's positive and all on one side of the mat. I have a negative x on the right and an x on the left. So I want to get rid of this negative x. To do that, I need to add x. But if I do it to the right, I have to do it to the left. Oops, let's do that. Okay. And I have x plus x, which is 2x, and bring down your minus 2. Then on the right, I have negative 6, and then negative x plus x equals 0. It cancels out. So I'm just left with negative 6 on the right. Alright, now I've got my x's positive on one side. Let's get rid of anything else that's on that same side of the equation. I've got negative 2 on the left, so I need to cancel that out by adding 2. Alright, negative 2 plus 2 cancels out, and I have 2x on mat A, or on the left, and on the right I've got negative 6 plus 2, which is negative 4. Now I have 2x equals negative 4, so I'm going to divide both sides by 2, and I see that x equals negative 2. And you can go back and check that one on your own. For sake of time, we're going to keep moving here. Our next example says 10 equals x plus 5 plus x. First thing I'm going to do is compare my like terms here, and I see that I have x plus x, which is 2x, and I'm going to bring down my plus 5, and on the left I still have 10. Alright, now I want to get my x's alone on one side of the mat, so I need to get rid of this plus 5, and I can do that by adding negative 5 to both mats. Or you could take 5 away from both mats. It would give you the same answer there. So that cancels out. And I see I have 2x on mat B, and 10 plus negative 5 is 5 on mat A. So now we need to get x alone, so we're going to divide both sides by 2. And I see that I have x on the right, and then I have 5 halves. You can leave it as a fraction, that's perfectly fine. Some people don't like that and you want to turn it into a decimal. If you want to do that, then you do 5 divided by 2, which is 2.5. So x equals 5 halves, or x equals 2.5. This will be the last example we do together, and I'll give you a few you can try by yourself when we're done here. Alright, so when I look at this equation, I see over on the right I need to use the distributive property. Let me split this quick. Need to use the distributive property to get rid of those parentheses. So I'm going to take 4 times x, which is 4x, minus 4 times 2, which is 8. And now I'm going to, I can combine terms over on the left right away if I want to. I've got 6 minus 3, which is 3, and then I'm just going to bring down my minus x. Alright, and now I've combined all my like terms already and distributed, so I can try now to get my x's alone on one side and my unit tiles on the other. So at this point I see I've got a negative x on the left. I need to get rid of that. We wanted to go over and join the 4x on the right. So to do that I'm going to add the opposite, but I need to do that to both mats. And I see when I do that, let's draw my line here, I have negative x plus x cancels out, that equals 0. So I have 3 on the left, and then 4x plus x is 5x, and I'm going to just bring down my minus 8 over there. Now to get rid of that minus 8 I need to do the opposite, so I'm going to add 8 to both sides. And when I do that on mat A, that cancels out, mat B, that cancels out, and I'm left with 5x, and then on the left hand side I've got 11. So 11 is equal to 5x. Final step to get x alone is you divide by 5, so that we can get x all by itself, and I see now that x is equal to 11 fifths. Okay, perfectly fine to leave it like that. Somebody else might want to turn that into 2 and 1/5. Okay. And somebody else still might write their answer as 2.2 because maybe they did 11 divided by 5. All of those work. All of those are perfectly acceptable. I like to just leave it as 11 fifths. It's one last step. Might as well. All right. Let's see what you do here. If I give you a couple more examples to try, and bring these to class with you when you come in, and make sure you're showing each step like I did in my video too, so that I can see what you're understanding and what I still need to help with. So copy down the following problems, do them in your notebook, and bring them to class with you for tomorrow. These are the 4 problems I'd like you to do for tomorrow. Remember, you must show your work. It's up to you. If you think you're ready to do it algebraically like we did in the video, go ahead and try that, okay? If you're feeling like that's not making a lot of sense to you yet, go ahead and record it in a table. Either way, feel free to build them with tiles, just to make sure that you're feeling really comfortable as you go. Bring your work, bring your answers with you to class tomorrow, and we'll go from there. Thanks for watching.